Hi everyone, today's lesson is day 3 for chapters 1 and 2, so let's get started. Today's all about solving equations. Learning targets are basically giving an expression. We're going to be determining whether or not the polynomial is a polynomial and to name it. Basically, we're classifying the polynomials. Multiplication of binomials, solving an equation, using inequalities, and transforming an equation. So let's get started. So write the inequality that represents the sentence. So 4 less than a number is greater than negative 28. We're going to use the value for a number. We're just going to use that as x. So 4 less than any number, so that's going to be minus 4, is greater than negative 28. The second question says twice a number, so we have twice some number, is at least, so it's that value or greater than 15. So that means that it has to be greater than 15. So it's at least. So that means it could actually even equal that value. So it's at least greater than or equal to 15. A number increased by 7. So some value greater increased by 7 is less than 5. The quotient of a number, the quotient means division, so that's any number and 8, so x over 8 is at most negative 6. So it has to be less than that value, so it has to be at most 6, negative 6. So it can't be more than negative 6. So it's either going to be less than or equal to negative 6. First degree inequalities. So solve each of the following right in interval notation. So then also we want to graph this. So let's get started. We're going to solve the first equation. I'm going to move the negative 2x over. And so by adding 2x to both sides, that's going to give me 5x minus 5 is less than 6. 5x is less than 11 because I'm going to add 5 to both sides. And then I'm going to get x is less than 11 divided by 5. So I like to put just 0 on the number line and also my value that I got. So we have 11/5. X is less than 11/5. So that means it's not equal to that value, but it's less than. So our arrow is going to go to that in that direction. Now, putting this in interval notation, what that means is it's less than that value, but see how this is going to infinity in the negative direction? So we're going to have a parenthesis with negative infinity, and because this is an open circle and it's not equal to 11/5, then what that means is that also will be a parenthesis because it's not equal to that. And the reason that why negative infinity is a parenthesis as well is because you're never going to actually reach negative infinity. The next problem here, I'm going to move the 7x to the other side. So then I have 17x, and then I've got a minus 4. And then on this side, I have 13. And so I'm going to add 4. So I have 17 is greater than or equal to 17x. I'm going to divide by 17 on both sides. And I'm going to get x is less than or equal to 1. So that means that I'm going to, again, put my value 0, and I'm going to put 1 here. It's less than or equal to, so that means that's going to be a solid circle. And going to the left, x is less than. So that means it's also going to the left. Putting this in interval notation, then because, again, negative infinity, so we're going to go negative infinity to 1. But because this is a solid circle here, this would become a bracket. And so that's what we call interval notation. So the next question says compound inequalities. When two inequalities are joined, you're going to have an and in between. And there's 2 ways to write this. This value here, this is the exact same question. And what they've done is they've broken that up. See, you have this equation here, which is negative 3 is less than 2x plus 5. And then you have this other equation that says 2x plus 5 is less than or equal to 7. So when you see something like that, you can split that up. Solving this, okay, let's get to doing that. I'm going to subtract 5 from both sides. I'm going to get 2x is less than or equal to 2. X is less than or equal to 1. I'm going to subtract 5. I'm going to get 2x is greater than, if I subtract 5 from both sides, right, that's going to be negative 8. which means x is greater than -4. So I have two answers. So what that means here for this question, I'm going to move this up just a little bit. What that means is when I graph it, I'm going to put my two values and put 0. I like to put 0 on there. Even though I'm not using 0, I like to put 0 on there. 1 here, and then you've got a -4. This one says x is greater than -4, but not equal to. So this is an open circle, greater than, going in this direction. And then up into 1, this says x is less than or equal to 1. So that means this is also equal to 1, but going in the left, to the left. Putting this in interval notation, you would say parenthesis -4, comma, and it's all these values here, including 1. So because it's including 1, 1 is going to be in the bracket. So the next question is a compound inequality, meaning two inequalities are joined, so or. So in doing this problem right here, subtract 5, so we're going to have 2x is less than or equal to, and if I subtract 5 from both sides, I'm going to get -12, which means x is less than or equal to -6. Or we have this equation where I'm going to add 5 to this side, and I'm going to get 2x is greater than 6, so x is greater than 3. So I'm going to use my little line here to put both of my graphs on the same graph. And so I've got, here's my 0. I have 3, and then I have -6. So this part of the equation says x is less than or equal to -6. So that means it could possibly be this value here is -6, but it's also less than. So it's everything in that direction that's going to the left. Now for 3, it says or, see or, x is greater than 3. So open circle here, greater than 3 is going this way. So that would be my solution for graphing, but also I would put it in interval notation. But because of the or, you've got two different things happening and nothing happening in between here. So what this means is to represent this part, this left side, that's telling me that it's -infinity. Remember, if it goes to infinity, you're going to have a parenthesis. And it includes -6, so that's a bracket. Also, together in the same question, we have that as a union, that's going to be 3, so a parenthesis, not including 3, and that goes to infinity, also parenthesis. So that would be my solution in interval notation. Write in interval notation. So this one's a little bit trickier equation. You just have to distribute first. So we have -6x plus 3 minus 5 is less than or equal to 3x minus 1. Let's see here. I'm going to combine some stuff here. -6x minus 2 is less than or equal to 3x minus 1. I'm going to go ahead and add 6x to this side, which, well, doesn't matter. Either way, actually, I'm just going to move it over. So minus 3x, change my mind. So I've got -9x. I'm going to add 2 to both sides, so plus 2. And so that's going to be 2 minus 1, which is 1, so less than or equal to 1. Now, remember when you divide or multiply by a negative number, what you're actually doing here, see that? I'm going to be dividing in this case. That's saying the opposite of that value. So keep in mind that when you have this negative sign here, it's telling you the opposite of that inequality. So that's going to flip it. It's going to change it. So instead of it being less than, it's going to end up being greater than. So I'm going to rewrite this here. -9x less than or equal to 1. Dividing by -9, I get x is greater than or equal to -1/9. So I'm going to draw my equation, or draw my graph, and I'm going to put my little 0 here, put my -1/9, and this says x is greater than or equal to, so could be equal to, so that's solid, and greater than meaning going to the right. Putting that in interval notation, that's going to be a bracket, -1/9, comma, infinity. For the next problem, it says the length of a rectangular yard is 30 meters. Whoops, that's a little bit odd. Let me fix that. The length is 30 meters. So we have a little rectangle. Our length is 30, and the perimeter, P, is equal to at most, which means it's got to be less than or equal to 90. So that's what at most means. Remember, perimeter is the length of all sides going around. So if this side was 30, this is 30. We're not quite sure what this side is. We want to find the actual width, which is the x value. So in doing that, we have two of those x's, or two widths, plus two 30s, so 30 and 30 is 60, is less than or equal to 90, because it's at most, meaning it can't be more, it's at most, it has to be less. So we have 2x is less than or equal to 30, x is less than or equal to 15. So that means that the width must be less than 15 meters. So you would say x is less than 15, less than or equal to. Okay, now this section talks about what a polynomial is. There is a fancy textbook definition, which is here. However, in simpler terms, basically it's the sum of terms where each term has a variable raised to a whole number power, not a fraction and not a negative. So this is an example of a 1, 2, 3, 4 term. You have 4 terms. Okay, I'm not sure why that, hello. Okay, hold on. Got a little question here. All right, so let's try this again. This is 4 terms, so 1, 2, 3, 4, so that's 4 terms. And additionally, if you look at the highest power, that's going to represent what kind of a polynomial it is. So this would actually, because it's the third power, this would be called a cubic polynomial or a 4-term cubic polynomial, okay? Something about polynomials, very important, is that polynomials are smooth. Their graphs are smooth anyways. There's no sharp points, so like it wouldn't be an absolute value. A polynomial is smooth. It's continuous, could look something like that, right? No gaps, meaning you can't start and then stop and then start over again somewhere else. There's no gaps. The domain is all real numbers, meaning left to right, those are all real numbers, okay? So talking about polynomials, they have specific terms for each one, so I'm going to go over those. We talk about the degree being n. N here, n would be my degree. That is always going to, the degree is always represented by the highest value, okay? A is my leading coefficient, and that goes with the degree, the highest power degree. We have a leading term, and the leading term, again, is the one with the leading coefficient and the one that has the highest power. And the y-intercept is this last value, which doesn't contain an x. If you notice that this is like x minus 1, so it's like decreasing. Well, if this is x to the 1 power, this actually would be x to the 0 power. But remember, anything to the 0 power is 1. So we really don't even represent 0 being there, okay? So if we're looking at this equation here, this looks like a parabola because it's an x squared term. So it's a quadratic. So it looks something like that. In this quadratic, it looks like it starts up 1. But basically, this here is something that it would estimate, look what it looks like. However, the real question is, what type of a polynomial function is it? It's a quadratic, yes, but in naming it, we're going to go with the quadrat. This is a second power, and second power are called quadratic. I have a leading term of 2, a leading coefficient of 2, and this whole term right here is my leading term. My leading coefficient, which is my LC, that's the value in front, okay? So that would be 2. The second value here, that's the constant. That right there is just this y-intercept here, and just being a value that where the graph crosses the y-axis, being the y-intercept. A couple of other things. So you would say you have 2 terms here, so that's called a binomial. So when you're actually labeling this equation, you would say that this is a quadratic binomial. And so that's how you would represent that. Now, a lot of people will say, well, wait, that's a second degree, because we know, see the 2, that's a second degree. I mean, it's not wrong to say second degree, but you should know that the second degree does mean quadratic. This one, remember, you have to go with the highest power. Like this one, this was x squared was the highest power. This value, keep in mind, actually had an x to the 0 power. Just like this is 2x to the 0 power. Definitely not the highest power. The highest power is this value right here, and that means that's my leading term. And so therefore, 3 would be my leading coefficient, and it would be a 6th degree polynomial. Now, we actually don't have a name for 6th degree, and I'm going to go in the next slide. We're going to go over all the different names, but we don't have one. So you would say that this is a 6th degree binomial is how you would represent that. So polynomials, and remember what we said in a couple slides prior, that binomials are smooth. So, or polynomials are smooth. So this right here, being a quadratic, of course, is a polynomial. So that's a yes. Definitely polynomials are quadratics, or they're binomials, or they're trinomials, but they're also equations. Remember, this is 3x to the 0 power. That's a smooth line. So that's also, yes, a polynomial. Now this one here, you're imagining that this keeps going on, as well as this one here. This polynomial, it's a cubic, actually it looks something like that. This one right here, also, yes, is a polynomial. So this would be a yes. No gaps inside. This one though, this also, yes, is a polynomial. See how it's smooth? It keeps going. Now these are non-polynomials, meaning polynomials they're not polynomials because they either have a sharp edge, they stop, there's a gap, something like that. Now this would be no, because absolute values are not polynomials. Additionally, the square roots, right, like that, not polynomials. This right here, not a polynomial. See how this is, I don't know if you can see that actually. That's x to the 4th, 5th power, not a polynomial. And this one, definitely not a polynomial, because you can't have variables on the denominator of polynomials. And see that? Those are asymptotes. And so that leaves a gap in between both of the parts of the graph. So asking yourself which one of these are polynomials, I would suggest you just take a minute, pause the video for a second, and try to figure that out yourself. Okay, so I'm assuming that you did that. This would be yes, because it's smooth, it's quadratic, yes. This one's an absolute value. This is not a polynomial. This one, see how the variable is on the denominator? That is not a polynomial. There are certain instances when you do not have a polynomial. Polynomials are not absolute values. Polynomials do not have a variable on the denominator. Polynomials are not values where x is under a root. So those are basically the three most important ones that you cannot have a variable on the denominator, which, don't forget, that would lead this to be x to the negative 1 power, so also not a negative power. This one would be yes, this is just a line, yes, this is a smooth line. This one looks like a cubic. And this one though, also look at that, that's a root. And also you can see the graph where it stops right here. That is not a polynomial, it's a square root, it's not. Okay, so in this slide, we're talking about examples of polynomial functions. So a 0 degree polynomial is something that looks like this. So you have x to the 0. You could have something like 5x to the 0. This is what we call, because that x to the 0 power is actually not there, right? So we call that a constant polynomial. And additionally, what this is here, constant polynomial, is this being just one term. This is called a constant monomial. Oops, misspelled that. Sorry about that. Because it only has one term. In this example, I only gave you one term. Okay. In this problem here, where I want a first degree, so that's anything with a first degree. So it could say, you could have something like 2x plus 7 or something like that. Because it's a first degree of 1, we call that a linear polynomial. Having trouble writing today, sorry about that. Now in this case, see how I have two terms? So if I were to write that out, this one would be a linear Okay. Binomial. Okay. Also, okay, so a second degree would look like this. So you could say x squared. You could say 2x squared. Or you could even say 2xy. Because if you look at these here, they're 1 and 1. So what that's doing is that's actually, you add up those. Remember when you're multiplying variables, you add the exponent. In this case, even though they're not the same variable, you're adding these exponents, and that's making the degree of this polynomial. So this right here, just let's say 2x squared, that is called a quadratic. And because I only have one term here, that's a quadratic monomial, okay? But, I mean, you could have lots of things. You could say 2x squared plus 3x plus 4. And in this case right here, it's still quadratic, but we have 3 terms. So remember, you identify the degree by the highest power, and this being the highest power, the 2, because that's 1, and then that's x to the 0 power. So that's the highest power. So you would say it's a quadratic, and because it has 3 terms, it's a quadratic trinomial in that case. A third degree power, like this, x to the 3rd power, you could say 5x cubed plus 2x, or 2x squared plus 3x plus 5, that's a cubic. See this 3rd power here? That's called a cubic. All right? And so because I have 4 terms and we don't have a name for a 4-term polynomial, we call it a 4-term cubic. However, if I got rid of, I don't know, let's say 2 of these terms, it would still be a cubic because the 3 is the highest power, but this would be a cubic, and then because it has 2 terms, it'd be a cubic binomial. For 4th degree, that would look something like this. You could have, say, 2xy squared z. That's a 4th degree because that's z to the 1 power and x to the 1 power. And remember, that would be 2, 3, and then 4. Do not ever count the constant, the number, the value that is the coefficient in the front. That doesn't count ever. And so for this polynomial, you've got 2, 3, 4, 4th degree. You also could just say 3x to the 4th power. And so again, we call that a quartic for a 4th degree. So depending on how many terms you have, if it's 1 term, it's a monomial. If it's 2 terms, it's a binomial. If it's 3 terms, it's a trinomial. And if it's anything more than 3 terms, like a 4-term or 5-term or 6-term, you just say it's that term polynomial. A degree of 5, I can say 3x to the 5th power. So that would be what we call a quintic monomial because I have 1 term. But if I added, let's say, 3x squared plus 6, that would be a quintic, because remember, you take the highest power, that would be a quintic trinomial. If I just lost one of my terms, that would be a quintic binomial. So you're still taking, the polynomial is defined by whatever the highest power is. Keep in mind also that other ways that you can write that is, you could say 2x squared y squared, that's 4 terms, that's not a quintic, and then maybe a z, like that. That would be 2, 4, 5, so that would be a quintic. Polynomials and not polynomials, okay? So again, this, right, just labeling these, just going off and just labeling these here, that's a 1, see this 1? That's a linear monomial. This one right here, see that's 1 again. That's a linear binomial because it has 2 terms. This x is not on the denominator. I think that's kind of hard to read. That it should look like this, 7, 9, and then x. So that's 2 terms, so it's a binomial. The highest power is a 2, so that's squared, so that means it's a quadratic. So that'd be a quadratic binomial. This one, look at the highest power. That's x to the 0, not highest. 1, xy, that's 2. We have 2, 3, 4, and then 1, 2, 3. So this is actually a 1, 2, 2, 3, 4, 4th power, which we call 4th power's quartic. And then we have 1, 2, 3, 4, 1, 2, 3, 4, 5 terms. So it's a 5-term quartic. v to the fifth and w to the fifth are both to the fifth. So this one is called a quintic, and two terms make binomial. This would be x to the 0, and because of that, it's a 0 power. We call that a constant. And a constant, because it only had one term, is a monomial. And I guess I should put linear here and also linear here. These are not polynomials. This is kind of important because things that are not polynomials, oops, that's not going to work. Let's see. Well, anyway, I'll just go over this. See how the y is to the -2? That means that the y squared would be below, not a polynomial. You cannot have an exponent that's negative, or you cannot have a variable on the denominator. This second example says 2 over x minus 2. Again, you can't have a variable on the denominator, definitely not a polynomial. 1 over x, variable on the denominator, no. No absolute values either, and no square root values. Remember, if you could write a square root as a power, but if the power is not a whole number, it's not considered a polynomial. So these are just different terms. This is my constant term. We actually went over this before. The linear term, because this is to the 1 power. This is my quadratic term because it's to the 2nd power. And this whole term here, that's a quartic. It's to the 4th power. And this 2 is actually what's called the leading coefficient. So just naming these polynomials, so let's do that. This is to the 6th power. We don't have a name for that. So you would say it's a 6th degree. And remember, check and make sure that that's the highest power. It is. And we have 3 terms. So that's a 6th degree trinomial. This one is 3rd degree here, +1, +1, so 3, 4, 5. So that's a 5th degree, but we call 5th degrees quintics. So that's a quintic, and I'm not quite sure how many terms this is going to be. 3, 4, let's see here, 5. So that's a quintic. So that means there's going to be 6 terms, and that's something that we'll talk about later in the class. This is a 3rd, not 3rd, because not 2nd, because 4th degree is the highest power. So a 4th degree we call a quartic, and we have 4 terms. So this, you would say that this is a 4-term quartic. That's the name of the polynomial. Equations that have absolute values. So one thing to remember about absolute values is that you have 2 values for x that could, once you take the absolute value, it could be positive or it could be negative. So you have to allow for that. So we're going to allow for x minus 5 equals 3, the positive value of that. And then I'm going to put it on the left side. Some people put it on the right side, and either way is going to work for you. You just decide which one is better for you. So we have the positive value and we have the negative value, okay? So we have x, we're going to add 5 to both sides. I get x equals 8. I'm going to distribute, I get negative x plus 5 equals 3. Subtract 5, I get the opposite of x equals negative 2, x equals 2. And of course, you can always check your answer to this x equals 2 and x equals 8. It's an equation. I'm going to put my answers in solution sets, and I'm going to try to put them in increasing order. So we're going to say 2, okay. I'm going to say 2, and then I'm going to say 8, okay. Some more absolute value problems. For this problem here, I would actually divide by 2 first. So I'm going to have the absolute value of 3 minus 14x equals 5. And so now that I have my absolute value, I'm going to allow for both solutions. And in this case, we're going to see 3 minus 14x equals 5. And we're going to see the opposite, parenthesis, of 3 minus 14x. Okay, hold on one second. Let me rewrite that. So on this side, I'm going to rewrite this, and I'm going to get 3 minus 14x, and then equals 5, and make sure that that's a negative, because that's the opposite. One's positive, one's negative. So I'm going to, let's see, subtract 3 from both sides. So if I subtract 3 from both sides, I get negative 14x is equal to negative 2. X is equal to 2 over 14, which is 1 over 7. So there's one of my answers. I'm going to distribute this negative sign, and I'm going to get negative 3 plus 14x equals 5. I'm going to add 3. I'm going to get 14x is equal to 8. And then x equals 8 over 14, which is going to reduce by 2 to 4 over 7. So my two solutions for this problem are going to be 1 over 7 and 4 over 7. Put those in solution sets for each of these absolute value problems. For this problem here on the right, I would actually add 4 first. So we have the absolute value of 3x plus 1 is equal to, if I add 4, I get 3. So I'm going to split this up, and I'm going to get 3x plus 1 is equal to 3. And the opposite of 3x plus 1 is equal to 3. Subtract 1, I get 2. So 3x is equal to 2. X equals 2/3. I'm going to distribute the negative sign. I get negative 3x minus 1 equals 3. Add 1. Negative 3x equals 4. And then x is equal to negative 4/3. So putting my answer in solution sets, I'm going to get x equals negative 4/3 as well as 2/3. And remember, two solutions, this is funny, two solutions for every absolute value problem. It's very important. Next question, just one more. This is about absolute values, absolute values and inequalities. So let's talk about that. So we know we're going to have two solutions, right? So we're going to have 3x plus 2 is less than 5. And we're going to have the opposite of 3x plus 2 is less than 5. So we're going to get 3x is less than 3. So x is less than 1. And then for this value, we're going to distribute that negative sign and get negative 3x minus 2 is less than 5. We get negative 3x is less than 7. And then x is less than, nope, greater than, because remember, this is saying the opposite here. See this negative sign? That's saying the opposite, which means that I need to flip that equation. So they flip this inequality. So then when I divide by negative 3, it's now going to be x is greater than negative 7/3. So graphing this, I'm going to put this on a number line. I'm going to always start with 0. I've got my 1 here, and here I have my negative 7/3. So this says x is less than 1, which means not including, so it's an open circle. Going to the left, x is greater than negative 7/3, so that's going to the right. So these are the values in here that satisfy my equation. So I'm going to put that in interval notation, and that's using parentheses, so negative 7/3 all the way to 1, and both of those are parentheses because the brackets would include that. Okay. Just a note on going back on one of these, I just wanted to let you know that if you were to graph one of these equations, right, here's 0, just note that you can graph these. Here's 1/7 and here's 4/7. Just note that these are actual values for the solution. So this is 1/7 would just be 1/7, and 4/7 would just be 4/7. So there's not greater than or less than. So the only time you're going to use the, interval notation with these equations is if you do have an inequality. So that concludes this video. This basically is just talking about what your homework is for this week. You have worksheet 1.4 and worksheet 1.5/1.6, which is 1 page. So they're both 1 pages, front, back. You already get your syllabus signed, and also make sure that you check Canvas. And thanks for watching the video. I'll see you next time.